Okay, question 21, last question of the paper. Starting with n is an integer, explain why 2n plus 1 is an odd number. This is actually relatively simple, especially for the last question of the paper. We start with 2n is even, since 2 times anything is even, and plus 1 makes it odd. Take an even number, add 1, you get an odd number. That is sufficient for 1 mark. The real meat of this question is in part B. 5 marks, we're going to have to do a fair amount of work. Prove that the difference between the squares of 2 consecutive odd numbers is a multiple of 8. We're going to start with one odd number, which we already have, 2n plus 1. Now, the word consecutive, that means the next one along. The next odd number along is going to be 2n plus 3. Since 2n plus 2 would just be an even number again. So 2n plus 1 is our first odd number, 2n plus 3 our second odd number. We're asked to prove that the difference between the squares is going to be a multiple of 8, so we'll square each of our algebraic terms. 2n plus 1 squared gives us 4n squared plus 4n plus 1. 2n plus 3 all squared gives us 4n squared plus 12n plus 9. Next, we'll prove the difference between those terms is a multiple of 8. We're very close. Difference means subtraction. 4n squared plus 12n plus 9 subtract 4n squared plus 4n plus 1. 4n squareds will cancel. 12n subtract 4n will leave us with 8n. 9 subtract 1 will leave us with 8, for a net result of 8n plus 8. Factorising gives us 8 brackets n plus 1, which is a multiple of 8. And we are done.